Hi and a very good day everyone. Welcome to the first chapter of our course, CAD for Technical Modeling and Drawing. The topic we'll be exploring today is Introduction to Technical Drawing. In this chapter, we will cover 5 essential subtopics. These include 1. The definition of technical drawing, 2. The objectives of technical drawing, 3. The importance of technical drawing, 4. The product design and development process, and 5. The drawing tools used in both traditional and modern drafting practices. To make this content easier to digest, we've divided the lecture into 3 parts. Part 1 is titled Fundamentals of Technical Drawing. In this part, we will look at what technical drawing is, explore its main objectives, and discuss why it is so important in the engineering world. Part 2 will focus on the application of technical drawing in product development and manufacturing design. Here, we will go through the stages of product design, from research and ideation, all the way to prototyping and production, and see how technical drawings guide each step of the process. Part 3 introduces you to technical drawing instruments and software. This includes both manual tools like the T-square, protractor, and French curve, as well as digital platforms such as AutoCAD and SolidWorks. So, let's begin with Part 1, Fundamentals of Technical Drawing. By the end of this part, students should be able to distinguish technical drawing from artistic drawing, explain the definition and function of technical drawing, and identify its key roles in communication, documentation, quality control, process planning, and product innovation within engineering and manufacturing contexts. Let's begin with the fundamental question: what is technical drawing? Technical drawing, also known as engineering drawing or drafting, is a standardized graphical language used by engineers, architects, and technologists. It helps in conveying complex ideas, product specifications, dimensions, shapes, and materials without using words. Instead of describing how something should look or function using long paragraphs of text, a technical drawing conveys all the necessary information visually, and with high precision. It allows engineers, designers, and manufacturers to understand exactly what needs to be made, how it should fit, and what materials or dimensions are required. For example, if you are designing a reusable tumbler, your technical drawing will determine every aspect of its production, from the shape of the lid to the diameter of the body. The accuracy of that drawing directly affects how well the final product matches the intended design. If there is a mistake in the dimensions of the tumbler's lid or bottle, even by a small margin, it could lead to functional issues such as leakage. This not only affects the usability and quality of the product but can also result in customer dissatisfaction. More importantly, such errors often require reworking the design, producing new molds, or halting production, all of which can incur significant additional costs and delays. That is why accuracy in technical drawing is critical. This is an example of a technical drawing, more specifically a 2D drawing, which presents the product from multiple views, typically the front, top, and side. These multiple perspectives provide a clear and complete representation of the object's geometry. Each view includes precise dimensions to ensure every edge, corner, and feature is accurately communicated. Before we go any further, let's pause and reflect on a simple question: what does drawing mean to different people? If you ask an artist and an engineer the same question, what is drawing? Chances are, you'll get 2 very different answers. Take a look at this slide. It offers a creative comparison between artistic drawing and technical drawing, clearly showing the contrast in purpose and approach. This might just represent the kind of responses you would get from both individuals. An artist might describe drawing as something emotional, expressive, and full of creativity, a space to explore imagination and aesthetics. Meanwhile, an engineer is likely to say that drawing is about clear picture instructions, a way to communicate exact information for building or making something. As you can see here, on the left side, under technical drawing, we see icons like a computer monitor, magnifying glass, and mouse, all tools that reflect precision, analysis, and structure. These elements are typical in fields like engineering, architecture, and industrial design, where drawings must follow strict standards. On the right side, under artistic drawing, you'll notice symbols like a flower, butterfly, and sun, representing creativity, emotion, and free interpretation. These drawings are meant to inspire and evoke feelings, not necessarily to instruct how something should be made. This contrast helps us understand that while both types of drawing involve visual expression, their intentions are completely different. One is open-ended and expressive, while the other is exact and instructional. Artistic drawing is something that's very subjective. It's open to interpretation. One person might look at a piece of art and see one thing, while someone else might see something entirely different. It's not meant to be exact or literal. Instead, artistic drawing is all about expressing emotions, imagination, and personal meaning. It allows the artist, and the viewer, to bring their own experiences and feelings into what they create or see. For example, take a look at this picture. Do you see a duck or a rabbit? At first glance, I saw a duck. But some of you might immediately see a rabbit instead. So who's right? The truth is, nobody is right, and nobody is wrong, because the image itself is ambiguous. It's a great example of how artistic drawings can be interpreted in different ways depending on the viewer's perspective. In contrast, technical drawing is the complete opposite. It's designed to be absolutely clear in what it shows and represents. There's very little room for interpretation, because everything needs to be understood the same way by everyone who uses it, whether it's a designer, engineer, machinist, or manufacturer. Technical drawings follow strict rules, standards, and conventions to make sure the intent is communicated accurately and without confusion. These drawings are meant to convey exact dimensions, tolerances, materials, and specifications. In short, technical drawing is all about clarity, precision, and functionality, not artistic expression. It ensures that what is drawn can be consistently and correctly built in the real world. Now that we've explored what technical drawing is, let's take a closer look at its main objectives, or in other words, why we use it in the first place. One of the primary purposes of technical drawing is communication. It allows engineers, designers, and manufacturers to visually convey technical ideas, product designs, and detailed specifications. Unlike written descriptions, which can be interpreted differently by different people, technical drawings use standardized symbols, lines, and dimensions to ensure everyone involved in the project shares the same understanding of the design. Another important function is documentation. Technical drawings serve as a permanent record for every component, from individual parts to entire assemblies and systems. These records are essential for future reference, regulatory compliance, audits, and ongoing maintenance. They preserve the original design intent and can be used even years after a product has been released. Technical drawings also provide manufacturing guidance. They act as instruction manuals for machinists, mold makers, and technicians during the fabrication process. A good drawing includes all the necessary details, such as dimensions, material specifications, and tolerances, to ensure that each part is produced exactly as intended, with no guesswork involved. In terms of quality control, technical drawings are the standard against which products are measured. Inspectors and engineers use them to verify that each manufactured part complies with the required tolerances and dimensions. If there are discrepancies, the drawing provides the reference needed to correct the issue and ensure consistency across production. Finally, technical drawings support the entire product lifecycle, from the early design phase to prototyping, production, and even maintenance or upgrades. As products evolve, drawings help teams track changes, update components, and ensure smooth integration with other parts or systems. In this way, technical drawings are not just a design tool, but a strategic asset throughout the life of a product. Let's dive a little deeper into why technical drawing is so important in real-world practice, beyond just being a classroom concept. Technical drawing plays a vital role in ensuring precise communication throughout the design and manufacturing process. In industries of product manufacturing, accuracy in mold design, part specifications, and tooling is crucial. A technical drawing eliminates ambiguity by clearly conveying all necessary details, such as shape, size, materials, and tolerances so that everyone involved understands the product in the same way. This helps avoid costly errors and misinterpretations. Now, let's say you're working with a tooling supplier in another country. You might not speak the same language fluently, but a well-prepared technical drawing eliminates that barrier. It clearly lays out all the critical information, such as dimensions, tolerances, materials, and finishes, so the product can be manufactured exactly as intended, no matter where it's being made. It also serves as a key tool in quality control. During production, manufacturers and inspectors refer to the technical drawing to verify that a product meets all required specifications. Whether checking the diameter of a bottleneck or the alignment of snap-fit joints, the drawing provides the benchmark for dimensional accuracy and conformance. Without it, there would be no reliable way to confirm that parts are made correctly. Another important function of technical drawing is documentation. Every finalized drawing becomes part of the official design records. These documents are useful for future reference, whether for redesigning a part, performing maintenance, or meeting compliance standards. Technical drawings ensure that the original design intent is preserved, even when the team or location changes. In addition, technical drawings are essential for process planning. They help production teams determine how a part should be made, guiding machining operations, mold setups, and assembly procedures. The information in the drawing supports decision-making on tooling, materials, sequence of operations, and even cost estimation. Finally, technical drawing plays a key role in innovation and prototyping. With modern CAD and CAM tools, ideas can be quickly translated into digital models and physical prototypes. These drawings enable designers to experiment, refine, and test their concepts, accelerating product development cycles and encouraging creativity, while still ensuring everything fits and functions as intended. In short, technical drawings are not just helpful, they are a vital tool in ensuring products are built correctly, efficiently, and to specification.